Hi everyone and welcome to this lesson. Today we'll be learning the importance of linear functions that are perpendicular. So here we go. In this example we are given these two straight lines and we can see that they are perpendicular. We want to calculate the equation of this yellow line, which is called line G. Now, when we want to calculate the equation of a straight line, we need to calculate the gradient, but it's quite difficult to calculate the gradient of this line because we only have one known point, which is -1 and -3. If we had another point that was known on this straight line, we could have used the gradient's formula. So now we have to calculate the gradient in a different way. And we can now see that these two straight lines are perpendicular. So in other words, we can use that information. Now how? Let's go and see. When two lines are perpendicular, when we multiply their gradients, the answer should be -1. So in other words, if we look at this purple line and we are given this equation, we can see that that purple line's gradient is -1/2. So let's write that down. The gradient of f is equal to -1/2. Now we know that if we multiply the gradient of f with the gradient of g, we should get an answer of -1. So that means we can easily calculate the gradient of g. So all that we do is we take the gradient of f and we use its reciprocal. So this is 1/2. So the reciprocal means we're going to swap these two around. So in other words, 1/2 becomes 2/1 and 2/1 is 2. But then we have to do something else as well. This sign is negative, so for the other gradient the sign should be positive. Now don't make the mistake of thinking that you're immediately correct, just make sure. So we're going to multiply these two just like here and see if our answer is -1. So -1/2 times 2 is -1. So now we know we are correct and the gradient of our yellow line, which is line G, is equal to 2. And now we can use our reason because fx is perpendicular to gx. That is what was given here. So now we have the gradient of g without even having these 2 points on the straight line. So see, that is why it's important to know when linear functions are perpendicular, we know that when we multiply their gradients, the answer should be -1. So if we have the one gradient, we can easily calculate the other line's gradient. Now, let's continue. We write down y equals mx plus c. And in the place of m, we can put this 2. So, in other words, we have y equals 2x plus c. And now, in the place of x and y, we can put any point that's on the straight line. And we've got one point, which is -1 and -3. So, in the place of x, we're going to put the -1, and there it is. And in the place of y, we're going to put the -3, and there it is. And then 2 times -1 is -2. If we take the -2 to the other side, it becomes +2. And -3 plus 2 gives us -1. So the y-intercept is -1. And now we can write the equation of gx. So gx is equal to 2x, where 2 is the gradient that we calculated. And -1 is the y-intercept. And we can also see if we are correct because this lowest point of this point is -3. So that point there where the line crosses the y-axis is our y-intercept. And it's way possible that it will be -1. Do you see? Because this is -3, that should be -1. So we can see that we are correct. See you again next time. Bye.